Should have been recording this as we went. If you're at home, you can copy this down. Okay. All right, so here's the rule. This symbol right here is a Greek letter called theta. Represents any angle. Okay. Greek letters in trig are almost always used for angles. Alright? But the tangent ratio is the length of the opposite leg divided by the length of the adjacent leg. That's the tangent ratio. And we shorten that down, of course, and say opposite over adjacent. Tangent equals opposite over adjacent. And so, what's the ratio tangent A? What's the tangent of angle A ratio? Louder, please. CB over CA. The opposite over the adjacent. That's correct. Okay? What is the tangent ratio to angle B? Someone new. Louder, please. Okay, and so what sides are they? Where's angle B at? Is it right here? Yeah. You said opposite over? No. It's opposite over adjacent, right? Now, just to clarify, I thought I heard you say AB. And what did this rule right here say about the hypotenuse? It's never opposite or adjacent. And so this side is the longest side of the triangle. It's opposite the 90 degree. What side is that? The hypotenuse. So that can't be part of my tangent ratio. Okay? I'm glad you took one for the team, though, to say that, because other people will do it on the test, and we need to hear it, and we need to see how we can make that mistake. Okay? Because this side is touching this angle, right? And that's kind of how I described adjacent, the one touching it. But it doesn't count as adjacent because it's the hypotenuse. So where is the opposite side? C. Opposite angle B is CA. And what is adjacent angle B? Bless you. Louder, please. CB. What do you notice about the tangent of angle A and the tangent of angle B? They're switched, meaning they're, what's that R word that represents it? Reciprocals of each other, right? They're flipped over, right? They're actually also called the multiplicative inverse. That's the fancy word for reciprocal. Okay? Multiplicative inverse. Okay? That's the technical term. The normal term we use is reciprocal. And if you get really slang, let's try to stick with they're flipped over from each other. Let's try not to say things like opposite or switched around because that can be a little too vague. Okay? But they're flipped over from each other. I agree with that. All right? All right. Now we have a situation here where we want to find how far it is from Evan's house to Jessica's house across this lake. And we can't measure the distance, so we want to know. And so what we're going to do find that distance is we're going to create a right triangle. And we're going to use our tools to make sure it's a right triangle. Okay? It looks a little off, doesn't it? Well, it's not
Look
horrible.
at it like this.
It's not horrible. This is my right angle. So we'll pretend it's okay. All right? And then we measured this distance to be 20 yards. Okay? Let's make it 220 yards. All right? And we measured this angle to be 82 degrees. It's not. Drawing not to scale is what it would say on this picture. Okay? But anyway, we measured that, and we had tools to do that so that they're fairly accurate. All right? And we want to find the red line. We'll call it X. Okay? Well, in relationship to this angle, where is the X side? Opposite. And where is this 220 yard line? Adjacent. And we just learned that the tangent ratio, so tangent of our angle theta, is equal to opposite over adjacent. And so now if we substitute in what we know and don't know, we say tan of what? 82 equals x over, what'd you say? 220. Okay? Tan of 82 equals x over 220. And so if I want to solve, I just have, here's the tricky part. People treat this like it's two things. They treat it like it's a tangent and it's an 82. And sometimes they do strange things and they try to multiply that tangent and that 82. And they separate the two as if they're two different things. I'm warning you not to do that. That is not the proper way to handle that. Circle it if you want. Put it around parentheses if you want. That is a number. Okay? It's one number. It's not two numbers. It's not two different quantities. It's one number. And if I ask you right now, if I put 100 questions on the test that said tan of 1, tan of 2, tan of 3, tan of 4, tan of 5, you would get them all right. Am I right? Mm-hmm. You can take your calculator and you can find the tangent of 1, can't you? Mm-hmm. Okay, tell me right now, what's the tangent of 82? 7 point what? 7.11. Okay? But it's a number, right? Does it end? No. No, it doesn't end. It's a messy number. But, nonetheless, it's a number. Okay? And you have to treat it that way. So we have a number like 10 equals x over 5. How would I solve that equation? Multiply both sides by 5. So I multiply both sides in this case by 220. And here's the problem. Remember this long discussion over don't treat it like separate quantities? Some people take that 220 and times it by 82. There's not an 82 there, is there? That's not 82. It's the tangent of 82, which is 7.11. Right? So don't do that. Don't multiply that angle by this number. That's not how it can be treated. Okay, if you treat it that way, it's going to be wrong every time. So whatever you have to do to remember, circle it, parentheses, group it together, or maybe you just now know. You have to treat it as a quantity, one quantity. And so what's 220 times tan of 82? Oh, by the way, you don't want to round this off and then times it by 220. You're going to get a rounding error. 1,565. Okay. Well, our tools were a little crude, so they probably told us just to the nearest yard. And so we're going to round it off to 1,565 yards. That's how far it is across the lake. Okay? Any questions on that? All right. Just some flat out examples here real quick. I'm taking up way more time than I wanted to. The next one it won't take long because this is how to solve them and the others are just to make sure you know the ratios. This is a number, right? There's a shortcut to this. When our unknown is in the bottom, we can treat it like a proportion, cross products, and then solve. The result is these two are going to switch places. That's going to be the result. Okay? And I'm going to get x times tan 50 equals 1 times 6. And I'm going to divide both sides by tan 50. My answer is going to be x equals 6 over tan 50. Okay? I'm just cutting right to the chase for you. That's what's going to happen. Whenever the unknown is in the bottom, you're going to just switch places with these two. And that's going to be the result. That's how you can solve. So what is 6 divided tan 50? Everybody do it, because I want to know you're using your calculator properly. I want to make sure we're in degrees, and we're all getting the same answer. 5.0345?
Yeah.
So 5 point, but 3 keeps it still, if I just go to the tenths place. Okay? Make sure you got that. If you didn't get that, then we need to talk about how to use our calculator. Okay? What's missing in number 2 here? The angle, right? Yep, let's call it what it is. It represents an angle. So it's the angle is missing. And so how do I solve for the angle? Well, we have a feature on our calculator that's usually the second. Tan. And it says A then would equal the inverse tan of 72 divided 61. Now it's important that I put this in parentheses unless my calculator automatically does it for me. Or if I have the kind of calculator that I use the tan button later, I would go 72 divided 61 equals, and then I would hit second tan. So let's make sure we know how to find the angle on our calculator.
49.7279.
So 49.7 degrees. Anybody not get that? If he's the only one that got it, I don't want to take his word for it. Make sure we all know how to use our calculator. Okay? Again, we've already done solving, how to solve. Come on. I'm in a hurry and you're slow. There we go. Here's the sine ratio. It's the opposite over the hypotenuse. You can just put these together. You don't have to do separate notes. 9-1, 9-2 notes. I'm going to look for them together. Okay? And cosine is adjacent over hypotenuse. Say that again, please.
We don't have to write the whole length of opposite.
You should do it how you did the tangent one. They should all look the same. And then we're going to look at this. I don't know how many of you have ever seen this before. This acronym helps us keep these in order. Some people this is really helpful for. I actually never heard of this until I started teaching. Some kid told me about it. It was never taught to me. But anytime I get little acronyms, little hints, things that help other people remember, And I try to share it with you because it might help you. Okay? And I give a really lame story. I hate to have this recorded, but I'll do it anyway. It's kind of embarrassing. It's stupid. It makes you think, man, that's the dumbest thing I ever heard. But sometimes it helps you remember. How many of you ever got up in the middle of the night, go to the bathroom, get a drink, whatever, okay? And you walk around the corner of the bed, boom! Stub your toe right in the foot of the bed, right? It hurts, doesn't it? You know the only thing you can do for a hurt toe? Soak it. The only thing you can do is soak a toe up, okay? So-ka-toa. That's all you can do for a hurt toe, all right? So means sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Toa, tangent equals opposite over adjacent. So-ka-toa. Okay? So make sure that you know those three rules. You have to get really good with them. You can't mix them up. You cannot call the hypotenuse an opposite side or an adjacent side. Okay? If you want right answers, you want to do things correctly and score really well on the test, you can't do those things. All right? This first chapter only has 5 lessons. It's going to be pretty quick. We're going to take, though, we've got a couple activities we're going to do next week, and we're going to spend a couple days on each of the lessons, and so next week will be just focused over 9, 4, and 5, and then we'll have our Monday review and Tuesday test probably of the next week. Okay? Any questions on that? Which ratio should I use to solve this? What is this side? Hypotenuse. What is this side? Which ratio has adjacent and hypotenuse in it? Cosine. So we would say cosine of 30 equals 15 over x. Now how did I tell you to solve that? Nice and loud, somebody. What do we do? Yeah, we switch places with these, right? Whenever the unknown's in the bottom, we can switch places. Whoever said cross multiply, that's exactly what we're doing. This is just the result. X will equal 15 over cosine 30. Okay? In relationship to the angle we're looking at, what side is this? Opposite. What is this? Which ratio is that? Sine. So we say sine of 17 equals opposite over hypotenuse. Again, it's the unknowns in the bottom. Switch places. Okay? If I had something that looked like this, which ratio is that? Adjacent and hypotenuse, which is cosine. So how do I set it up? Nice. Cosine x equals 8 over 16. How do I solve? X equals inverse cosine of 8 over 16. Again, that's going to be second, but not tangent, second cosine. Okay? All right. You feel you have a pretty good chance here? All right, our assignment today is going to be this worksheet. Get out of the book a little bit, just get directly to a little practice. We've done some discovery and some investigating, and we've talked about it a lot. So now just some cold hard facts. Let's get a few done, okay?